Good morning and welcome to Unit 6, where now we are focused on quadrilaterals, four-sided figures. And our first lesson in Unit 6 is on a shape called a kite. Now a kite is kind of an irregular shape because not all of its sides are congruent, for example. In this lesson we'll be going over the properties of a kite and then how we can solve, use what we know about a kite to solve for how long certain sides of it are, or look at what happens with its diagonals and its angles. So first we need the definition. A kite is a quadrilateral with two pairs of adjacent sides congruent to each other. Adjacent means next to. So if we look at the diagram, what we're saying is that one of the sides, CD, is congruent to another side that is adjacent to it, next to it, and that's CB. And then DA is not congruent to CD, as you can see, but DA is congruent to BA. So these are adjacent and congruent. These are adjacent and congruent. Now, you might see a line of reflection here. So one thing that we need to know is that kites map onto themselves after a reflection across one of the diagonals. In this diagram, the diagonal that we're talking about is CA. And because this is true, we could say that a rigid motion maps triangle CDA onto triangle CBA. Rigid motions preserve distance and angle measure, so triangle CDA is congruent to triangle CBA. We should also be able to see that we can say that they're congruent by side, 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 the third side, the reflexive property, CA. Okay, so now we're going to look at a diagram that is a little bit bigger, and we're going to say more about the kite. So again, we have CD congruent to CB, and we have DA congruent to BA, that's two pairs of adjacent sides that are congruent. And then we have the angles. So angle CBA is congruent to angle CDA. So we have we have one pair of congruent angles. Here that's angle D congruent to angle B. But now we're going to put in the diagonals, and when we put the diagonals in, we're going to see some other relationships that are formed. So if we draw a diagonal CA, and we draw a diagonal BD, Now the first thing that I want to caution you on is angle CBD, right here, is not congruent to angle ABD. This diagonal does not bisect angle B, does not bisect angle D. This angle is not congruent to this angle. So our diagonals CA and BD these diagonals are not congruent to each other. And then if we look at the diagonal interactions, one diagonal is bisected. And that's diagonal DB. So that means that we have these two line segments congruent to each other. We could label coordinate E here, the intersection of the diagonals. So then DE is congruent to BE. Then we have one diagonal bisects angles. The diagonal that bisects angles is CA. So we can mark those angles. Then finally, the diagonals of a kite are perpendicular. So that means we have right angles here. All right, so this is already on the reference sheet that you received, and you can really figure out a lot about a kite by drawing in its diagonals and looking at it, but you do need to know that a kite is a quadrilateral with two pairs of adjacent sides and be able to mark those up. You need to know that it maps onto itself after reflection over one of the diagonals. And as you are drawing in the diagonals, you're going to be able to see other congruent parts of the triangle, like this diagonal is bisected, so you have these segments congruent. This diagonal, the longer diagonal in this case, bisects these angles. So we could say, for example, that angle DCA is congruent to angle BCA. All right. Into a practice problem. In kite ABCD, the measure of angle DAE is 2x plus 5. And angle ABE is 3x plus 35. If angle DCE is 45, DCE, fill in all angle measures. Okay, so I need to think about what else do I know about a kite. So I know that a kite has diagonals that are perpendicular. So that means I have 90 degrees around all of these, right? So let's see what I can do with that. So if this is 90, then I have 45 plus 90 plus something equals 180. This is angle CDE. When I add these, sorry, this is my expression, my equation. When I add these angles and subtract from 180, I will find that I also have a 45-degree angle here. Then we said that this long diagonal bisects its angles. So that means that this angle is also 45 degrees. That means that this angle, so then we have 45 and 90 again, so then this angle must also be 45 degrees. Now, if we look over on this side, in this triangle, we have two of the angles. We have the 90-degree angle and we have the 2x plus 5. And then we have a blank up here. And in this triangle, we have a 90-degree, and then we have 3x plus 35, but we have a blank right here. But we said that this diagonal bisects angle C, also bisects angle A. That means that the expression for this smaller angle, EAB, is the same as this one, because these angles are congruent to each other. So that means I can also call this one 2x plus 5. That means that I now have three angles and I can add them equal to 180. So I have 2x plus 5 from here plus 3x plus 35 from here plus 90 equals a total of 180. Now combine like terms and use inverse operations. We have 5x plus 40 plus 90, so 5x plus 130 equals 180. Subtract 130. 5x equals 50, divide by 5. X equals 10. Then I can substitute 10 back in to find these other angles. So then, if I substitute 10 here into 2x plus 5, I get 25 degrees and 25 degrees here. Then if I substitute here, I get 3 times 10 is 30 plus 35 is 65 down here. And then you see that the triangle on top is congruent to the triangle on the bottom, or rather you should see at least that it must have the same angles, because you have 90, 25, and something. Here you have 90, 25, and something. That something is 65, so this must also be 65. So we started out knowing 90 degrees here where the diagonals intersect, and then we had a 45-degree angle here, and then we started to fill in the other angles in the triangle. Okay, you do round 1. In kite ABCD, the measure of angle BCE is 35 degrees. And the measure of ABE is 65 degrees. And we need to fill in the measures for all angles. Remember, we also know the diagonals are perpendicular, so we have right angles here. So now we're thinking about this diagonal bisects angle C, so this must also be 35. Then we have 35 plus 90 plus an angle equals 180. That's just if we're looking at one of these two triangles, 35 plus 90 plus something. That's angle CBE. 35 plus 90 is 125. And then so we subtract 125 from both sides and we get angle CBE equals 55 degrees. Then we have the triangle on top is the same angles as the triangle on the bottom, so this is also 55 degrees. Now we have 65 and 90 instead of 55 and 90. So with 65 and 90, we'll get 25 here, and we'll get 25 here. And then we see we have 25 and 90, 25 and 90. Down here is 65, so up here must be 65. All right. Determine the measure of angle CBA. So angle CBA is right here. So that's 55 plus 65. So 55 plus 65 is 120 degrees. Angle BCD, 35 plus 35, so angle BCD is 70. If line segment, so now we're not talking about angles here anymore. If AB, line segment AB is 5x minus 3, and line segment AD is 4x, determine the length of AD. Okay, so we said that a kite has adjacent congruent sides. So these two sides are congruent to each other, and these two adjacent sides next to each other congruent to each other. So AD is congruent to AB, so we can write AD equals AB, substitute 4x equals 5x minus 3. We get negative x equals negative 3. We divide both sides by negative 1. We get x equals 3. Then we take x equals 3 and we substitute it in because we want AD. So 3, AD is 4x, so 4 times 3 is 12. And this says centimeters. Great. One more problem to do. In kite KITE below, Km equal x squared minus 14. So this is the part of the diagonal on the inside. And MT equal 5x. I'm going to do other line segments in a different color. ME equal 3x. MI equal x squared minus 18. So we said that in a kite, one of the diagonals is bisected. So this should make it clear that EI is not bisected at angle M. M is not the midpoint of EI. But M is the midpoint, and you know this because I told it to you. M is the midpoint of KT. So that means we can take the pieces from KT and set those equal to each other. So this is Km equals MT. Km equals MT, then substitute for Km, you have x squared minus 14, MT, you have 5x. This is quadratic, so we'll solve it by setting it equal to 0. We'll subtract 5x from both sides. X squared minus 5x minus 14 equals 0. So we're looking for factors of negative 14, 1 times negative 14, that add to equal negative 5. So those are negative 7 and positive 2. So we're looking at x squared minus 7x plus 2x. That's the same as the minus 5x. Then minus 14 equals 0. Then from there, x times x minus 7 plus 2 times x minus 7 equals 0, x plus 2 equals 0, x equal negative 2, x minus 7 equals 0, x equal 7. Then in the context of this problem, do we want the negative x or do we want the positive x? If we look at the expressions here, we have, for example, 3x. So 3 times a number tells us how long something is. We want that number to be positive so that 3 times that positive is also positive. So that means that we are looking to use x equal positive 7. And now the question's asking, what is the length of ME? So ME equals 3x equals 3 times the 7 that we just came up with equals 21 units. And in this case we can call them units because in the problem it did not specify the units. And you have done it. You just looked at the first quadrilateral called a kite. Remember that a kite is a quadrilateral with 2 pairs of congruent sides that are next to each other. They are adjacent to each other. Nice job.